Hello there, calculus folks. Today's lesson on concavity, um, and POI, points of inflection is what that is. Um, Starts with a warm up. And it's about 15 minutes. And normally we do this in class, so you're going to do this at home before you start watching this video. So if you have not done the warm up, you should not continue, because I'm going to take it up very shortly. So do the warm up first, and then we're watching this video to take it up, and learn about what we learned. Okay, so first of all, the first one, you did a derivative and second derivative, then fill out a sign chart. Um, this one here, we're not that interested in. We can sort of see where the function is positive and negative straight from the graph. What I'm interested in, and what we've been interested in the last few days, is the first derivative where it's positive or negative, and we know that um, when it's decreasing, the function's decreasing, the first derivative is negative. When it's increasing, it's the first derivative is positive. In between, we get a local extremum, in this case, a minimum, and that's all good. But I'm really interested today in the second derivative. In this case, the second derivative was constant, and it was always positive, right? Second derivative was ended up being 2. And what I want to mention to you is the general shape. The shape is this, well, it's a parabola shape, a smile shape, an up shape, compared to the next one, which is another parabola, but it happens that the second derivative is always negative. It's constantly negative, and this is uh, the second derivative gives us this frown shape, the down, the downhill or frown, down frown. That's the second derivative is negative. Positive smile, negative frown. And then we can see more complicated functions where the derivative actually, or the second derivative actually changes sign. We see that up until it looks like maybe 2. Is this 2? Something like that. That it's a frown shape, right? There's the frown shape. And after 2, it's the smile shape. There's the smile shape. And in between, that's not a um, critical point, right? This is because the first derivative isn't 0, but it is something. It's where the second derivative goes from being negative to positive. This is actually what we'll learn later as a point of inflection. It goes from being a frown to a smile. It goes from being um, second derivative negative to second derivative positive. And that's what today is all about. So you've got this note in front of you. It looks nicer on mine than if you just printed it off on black and white. Maybe you print it off on a color printer and it looks awesome, just like this. So concavity and points of inflection. And of course, what we're into this new calculation, the second derivative. How does it help us sketch the graph? Okay, so from the warm up, we see a couple of things. We see that if the second derivative is positive, we call that concave up. That's the smile shape. And again, we could think of it as, well, the second derivative is the rate of change of the first derivative. And that's true. The first derivative, remember, is just the slope of the tangents, right? So that means if the second derivative is positive, it means the slopes are increasing. Notice that this slope is a big negative. This is a less big negative. That's like a fraction negative. And then in some place it'll be 0, and then it starts being positive. So this means that f prime at x is increasing, right? You could think of it that way. The slopes are increasing. The slopes are increasing. Same thing as concave down, down, frown, smile, and the slopes are decreasing. Um, that's when the second derivative is negative. If f double prime at x is 0, then f at x has a point of inflection. Usually, it has a point of inflection. We'll talk about that soon, because not always is this true. Um, but we see on this graph it was frown, then it's a smile, goes from concave down to concave up, and in between is a point of inflection. So what's all this usually stuff? Well, there are cases when the second derivative is zero, but there isn't a point of inflection. So this one is, I believe this is a quartic function, the basic quartic graph it's been transformed, it's been moved right and down. But we can see f at 3, the second derivative at 3 is equal to 0, but it's not a point of inflection. This is always concave up. However, there's another case. For instance, if the second derivative of a linear function, you take the derivative twice when you're given a line to begin with, well, it's 0. Well, that's 0 everywhere, but there's no point of inflection, right? So there are cases where the second derivative is 0 and we don't have a point of inflection. And to make things even more complicated, there are times when we have a point of inflection, but the second derivative isn't 0. So look at this one. And this is some sort of it's a cube root function. Here, you see how this is smile shape, this is frown shape. And the second derivative doesn't exist at x equals 5. The vertical, the first derivative doesn't exist, vertical tangent, and so the second derivative wouldn't exist either, but there's still a point of inflection there. So obviously, we're going to have to keep in mind these special cases about when we're looking for points of inflection. And I think we'll see that in our first example. So given the graph of y equals f of x shown, fill in the sign chart. All right, well, no problem. We'll start easy, because if this is just y equals f of x, then it's positive for all these, but there's 0 there. But at 3, it's 0, and at 5, it's also 0. Negative in between there, positive everywhere else. So I'm going to put those 2 points on there. Those are important points for me. I'm going to change color so you can see on my graph when I'm the first derivative. So where's the first derivative 0, first of all? Well, right there, it looks like, maybe at -4. Maybe here at 0. Where else? Right there at 4. And then if those are the cutoff points, we can decide where the function's increasing or decreasing, right? So along here it's decreasing, so the first derivative would be negative. Here it's increasing, so the first derivative would be positive. Decreasing, increasing. Okay, now for the new one. And this is kind of hard to practice. Okay, where is... Let's try and identify the points of inflection. So where does the graph go from being a smile to a frown? Well, I can see this is definitely smile shaped. So somewhere in between, maybe around there, maybe about -2, I get a point of inflection. Because this would be a smile, this would be a frown, and somewhere along here, it starts being a smile again, right? So from here to kind of hard to point out. Let's try and make it easier. It's probably right around there, maybe around 2, we'll call it. That this part here is a frown, and then the rest is a smile, right? So the second derivative, this part is a smile, so that's positive. Concave up, concave down, concave up. Okay, and then it says, then estimate critical points, increasing and decreasing intervals, points of inflection, and intervals of concave up and concave down. So the idea is, if we have this sign chart, these things should be easy to talk about. Critical points, well, we've got a minimum. Now, we don't know the outputs, so I'm just going to write a minimum occurs maybe I'll do this so it matches my graph, because which critical points is the story told to us by the first derivative, right? So here, a minimum occurs at x equals minus 4. I just want to point out there, the minimum occurs at x is minus 4. Notice that the second derivative was positive, right? Well, that kind of makes sense, right? Because the second derivative concave up gives us a smile shape. Makes sense that if I do have a critical point there, that I could check the second derivative whether it was positive or negative, right? So I'll come back in a second when we start talking about the second derivative. We also have a maximum occurs at x equals 0, and a minimum occurs at x equals positive 4. All right, now I'm going to add that stuff. Notice here, since it was in the middle of a smile, we know that the second derivative was greater than 0. Same thing over here, right? A critical point occurred at x equals 4, and the second derivative was positive. That means it must have been a smile. That must have been a smile. And the minimum, a maximum rather, occurs on the top of a frown. So this is the second derivative is negative, right? This is the frown. And so this combination of facts, that the first derivative is 0 and the second derivative is positive, automatically gives me that it's a minimum. That the first derivative is, circle those. That the first derivative is 0 and the second derivative is negative gives it to me that it's a max. So I can combine those facts. Increasing and decreasing intervals. Well, which fact gives us increasing and decreasing intervals? Well, that's the first derivative. We've been talking about that for a few days. So f increases on those values and those values, right? So -4 to -4 to 0, right? -4 to 0, and then 4 and up. Then f decreases elsewhere, but we'll list it. -infinity to -4, and 0 to 4. Points of inflection. Where's our points of inflection? Well, that's the story is given to us from our second derivative, right there. Point of inflection occurs at, we said there was 2 of them, right? We had one right there and one right there at x equals -2 and x equals 2. What else? Intervals of concave up and concave down. So f is concave up when the second derivative is positive. In the middle. Dandy. Okay. What I just learned, and we talked about this already. So we've identified through the first derivative that x equals a is a critical point, right? The first derivative is 0. Then, if the second derivative is positive, that is a smile shape, a U, upside right U shape, then we've got x equals a as a minimum. So 2 facts. First derivative is 0, second derivative is positive, it's a minimum. First derivative is 0, second derivative is negative, then it's a frown, right? on the top of the frown, then it's a maximum. More of what I learned. More of what I learned. The point CFC is a point of inflection if the second derivative changes sign. That was, doesn't this sound a lot like a min-max, right? Where the first derivative had to change sign for it to be a minimum or a maximum. Now for a point of inflection, the second derivative has to change sign. That is, the curve goes from concave down to concave up or vice versa. Frown to smile or smile to frown. Has to be. So, in summary, to find a point of inflection, you find the points where the first derivative or second derivative is 0. You find points where the second derivative doesn't exist. Then you check to see if the second derivative changes sign at these points. So that means we're adding the second derivative to the sign chart. And the sign chart expands and expands. We're used to talking about the second derivative on the sign chart when we did motion questions, right? Because the second derivative, remember, was acceleration. Note how similar this process is to finding max and min points. Very similar process, but we might get them mixed up, and we don't want to do that. I'm going to return in part 2 of the video to do our single algebraic example. That's it, but I'm going to come back in part 2.